Hello dear programmer, I welcome you all in the lecture series of Fundamentals of Data Structure. From the last session, we started with the advanced concept, that is sorting. We have seen the first technique is bubble sort. The logic behind the bubble sort is to compare the two adjacent elements, and if they are out of order, then a swapping has to be done. We have seen the bubble sort requires n-1 passes. So let me start with the next interesting method is the selection sort. In selection sort, successive elements are selected in order and they are placed into their proper place. The logic is that we need to find out the first smallest element in the list and then it is swapped with the value in the first position. In the second way term, we are going to identify the second smallest list and it is swapped with the value in second position. In this, the straight selection sort, the list at any moment is divided into two sublists. One is sorted array and second one is an unsorted list. Then this wall will work as an imaginary wall. Then at every pass we need to identify which one is the smallest element in the list, in the unsorted list, and then it is compared with our all elements in the list, and the smallest element from this unsorted sublist is exchanged with the element in the beginning of this unsorted data. So after each selection and exchange, the wall between the two sublists is moved one element. That means increasing the number of sorted elements and decreasing the number of unsorted elements. Each time we move one element from unsorted sublist to the sorted sublist. So we can say that we have completed one sorted pass. If we have a list of total n elements, then there are n-1 passes are required to completely rearrange the data. Let me see with example. Here array A is consist of total 8 elements. So in pass 1 we are saying that the first smallest element will be exchanged with the element at A of 0. So there is no any sorted elements. Then remaining elements we are identifying which one is the minimum element. Let 12 is the minimum element and 12 is swapped with 25. Means A of 0 and A of 4 are swapped. So we can say that 12 in its appropriate place. So this is the output of our pass 1. So at pass 2, the second element means we are getting these are the sorted elements and these are unsorted elements. Then from this unsorted element, next minimum element is identified. It is 25. That 25 is compared with, is exchanged with 57. So we are saying that our unsorted element are decreased by 1 and sorted element or the sorted array is increased by 1. So in the next pass, we are identifying which one is the next minimum element. Then the next minimum element is will be exchanged with the position A of 2. So 33 will be exchanged with the value of. So we are getting that 48 and 33 are being swapped. So like this fashion, at every pass, we are identifying that means after pass 3, the 3 elements are sorted. In means there are total n-1 passes are required. So we are saying that in pass 4, then fourth element is going to be swapped with the next minimum element and we identified 37 itself is a sorted element. So in pass 4, next 48 will be swapped with 57. Then next element means from this 92 to 57, we are identifying that 57 will be exchanged with 92. So after pass 7, we are identifying 86 and 92s are compared. It is in its proper place. So at the end of n-1 passes, we get all elements are in sorted manner. The sorting order in this selection sort is in ascending order. So here the number of passes are required n-1. As there are total n elements, so number of passes are 7. So let dear student will see that how to write down the selection sort algorithm. The input to that algorithm we are taking an array A which is not sorted. So what is the logic in that? We are taking that the first element, okay, and then from that next element to the last element, we are identifying which is the minimum element, and that will be swapped with the first position. Then that position is increased by 1. Means again from that next element, means if my I is 0, then j will be from 1 to n. We are identifying which is minimum element, and it is swapped with a of 0. Next one is a of 1. So j becomes 2 to n elements, and identifying which will be the smallest element, which is compared with a of 1. So like this fashion, we are writing that algorithm. So for this reason, there are total 1 minus n minus 1 passes are there, and we know that the first element itself is the sorted. So that's why our for loop starts with from 1 to n, and j will be required, which will keep the trace of the position of minimum element. Then we have been introduced the next counter k, which will start with comparing from I plus 1 to last element, and if it requires, then we are doing some swapping. So this is the logic of selection sort. So in that selection sort, currently we are saying that element is equal to 0, and then minimum index is that element which containing that minimum value. For that reason we are considering this minimum index, so which is set to 0, and temp is the one variable which starts with that current plus 1, means we are starting with the next element 2 plus 1, and then we are identifying which one is the smallest element, and that element is swapped with that minimum index. So like this fashion, our selection sort is working. Means if we are having this array A, then initially the current is equal to 0. So this current will be increased by 1, means all passes have been traced out. Then we are identifying that minimum index is equal to current, means this element is going to be swapped. Then we are requiring a one new counter, let it is temp. Then temp will be current plus 1. In this case, temp will be 1 till the last element. So among this unsorted list, the minimum index is identified by comparing that 57 itself is the minimum, and then we are comparing which one is the minimum. Accordingly, we get 33 is that, 12 is the minimum element. Then this 12 is pointed by the 10. So we can say that minimum index is equal to this 10. Then at the for identifying, means once we are confirming that 12 is the minimum element, then the element of A of current and the minimum element of A of minimum index are going to be swapped, and then this current will be increased by 1 position. So like this we are performing selection sort. So dear student, I expect you kindly pause the video and try to sort the following elements in the ascending orders using selection sort. Also identify that how many passes are required. I expect my student have been solved that example. Let me see what is the answer. Right. Here we are having the original list, which consists of total 6 elements. Then we are identifying that which one is the first minimum element, which is 8. Then 8 is swapped with 23. So our current is pointing to 78, and temp is pointing from 45 onwards. Then we are comparing which one is the smallest element. So we are getting 23 is swapped with 78. In the next iteration, 32 is swapped with 45. In next pass, 45 is swapped with 78, and in the last, so we are getting that 78 and 56 are swapped. So at the end of the pass 5, we find that all the elements are in their appropriate place. So here the total number of passes are n minus 1. So we require total 5 passes. So let me conclude. The selection sort in this the ith smallest element, and it is placed in the ith position. It is called as unstable sorting techniques. There are might be total n minus 1 passes we require. This is also called as the exchange algorithm, and the time complexity is big O of n square. Best case is also big O of n square, and average case is also having big O of n square. These are the reference book we have referred. Thank you. Happy learning.